Go ahead.
Okay. Yeah. Well, welcome to the Genesee Country Village and Museum. And today, as a Cooper at the museum, what I'm going to do is talk about how I determine the size of a bottom that fits in this bucket that I've made. So I've already cut the groove in the bucket. The groove is called a croze. That's spelled C-R-O-Z-E. So I cut this groove in the bucket. So now I have to make a bottom that'll fit exactly into that croze. Because if I make the bottom too small, it'll be loose and it'll leak. And if I make the bottom too big, it won't go together tight and the bucket will leak. So how do I find that? So you'll note that this is a circle. So Coopers of old had to find the exact radius of the circle that'll fit inside this croze, inside this groove that we have. So how did they do that? Well, what they did, unknowingly, many of them were illiterate, they applied a principle of geometry of the circle, a theorem in geometry of the circle that says that if you take any circle, divide that circle into 6 segments, 6 equal segments, each segment is an equilateral triangle. So to show you that, here's a circle. I've divided it into 6 equal segments. So it's kind of like a pizza or a pie that you cut into 6 slices, so each slice is exactly the same size. It happens to be that if you do that with any circle, each one of these triangles that are formed is an equilateral triangle, which means the radius and this radius is equal to the distance across the top. That's true for all of these triangles and for any circle that I divide that way. So Coopers of old were using this theorem without knowing it. And how they used it was they were given a pair of dividers, a compass, if you want to call it that. And they could use this compass to find the exact radius of the circle by applying this principle. So what they did first, they took the compass and they estimated the radius. But remember, it has to be exact. So they put it in and they estimated the radius. So we'll adjust it just a little bit here. They estimate my radius. And then they marked a point on the bottom of their bucket. And they went inside that groove, inside that croze that we cut, and they're going to mark off 6 segments. And they're going to keep doing it through trial and error until they end exactly where they started after they mark off 6 segments. So there's 1, 2, 3, 4, 5, 6. Okay, I'm a little bit big, so I'll do it one more time. We'll make a slight adjustment on my container or on my compass, and we'll do it again. 1, 2, 3, 4, 5, 6. Pretty close. So I'm right on. I've marked off 6 segments until I end exactly where I started. I take the compass. I'll take a piece of wood and scribe my bottom or trace my bottom because I know, based on that theorem, this is exactly equal to the radius of that circle. So a Cooper of old, many of them who were illiterate, they didn't really need to know anything about the theorem. They were applying that theorem. All they had to do was be able to count to 6, and they could find the exact radius.
Is there a name of the theorem that you know of?
No, I don't. I should look that up. Okay. Thank you.
The 6th theorem.
I should look it up.
Your name again is?
Jerry Walter.
Jerry Walter. Thank you, Jerry, from Genesee Country Museum.
Museum.
Great, thank you.